Every major AI lab on the planet just admitted something. Quietly. Not in a keynote, not in a press release, buried in research papers, in leaked memos, in the fine print nobody reads. For 5 years, the plan was simple. More chips, more data, more money. The model gets smarter. That was the whole game. It worked so well, people started saying things that sounded insane. Things like, we'll build a machine smarter than any human by 2027. And now, in 2026, that plan stopped working. Not broken, just pause, flattening. And the reason is one of the most fascinating stories in tech right now, because it's not really about computers. It's about running out of something nobody thought could run out. Let's start with the formula. It's called a scaling law. The idea is almost embarrassingly simple. Take a model, feed it more data, give it more computing power. Performance improves. Predictably, almost like math. This formula built everything you know. It turned GPT-3 into GPT-4. It turned Claude from a decent chatbot into something that writes code, passes the bar exam, holds a real conversation, and labs didn't need genius breakthroughs each time. Just a bigger data center, a bigger checkbook, so the checkbooks got enormous. The first transformer model, back in 2017, cost about $900 to train. GPT-3 cost somewhere between $500,000 and $4.5 million. GPT-4 blew past $100 million. Frontier training runs happening right now? $5 to $10 billion for one model. $900 to $10 billion in under a decade. That's not a curve. That's a cliff. And for a while, it was worth climbing. Every time you scaled up, the model got dramatically smarter. Until it didn't. Here's what changed. And it's not one wall. It's 3. Wall number 1, data. Language models learn by reading. Basically, the entire high-quality internet already got fed into these models. Books, articles, code, all of it. That well isn't bottomless. What's left now is lower quality, forms, noise. And this part is strange. Text that other AI models generated. So now models are sometimes learning from AI written text. Instead of human writing, feed a model too much of that. And it doesn't get smarter, it gets blander. Wall number 2, the plateau. And it doesn't hit everything at once. It hits skill by skill. Basic knowledge levels off early. Reasoning holds on a little longer. Coding improves a while after that. Only truly creative tasks keep improving significantly with size. So, just make it bigger, stop being a universal cheat code. It became a tool, one that works great for some things, and barely moves the needle on others. Wall number 3, money. When a training run costs a few $1 million, a bad result is a rounding error. When it costs $5 billion, a bad result is a headline. An emergency board meeting. An uncomfortable call with investors. Multiple insiders at major labs have described this exact scenario. A year of work, a mountain of compute, and the result is a modest, underwhelming upgrade. Even Ilya Sutskever said it out loud. The man who helped invent the techniques behind this entire boom. He said at a major AI conference that pre-training as we know it will end. That's not a skeptic saying that. That's one of the architects. So picture the labs right now, staring at 3 walls at once. Worse data to learn from, uneven returns depending on the skill, and massive costs for smaller and smaller wins. But here's the part that makes this genuinely fun. Pause. The response to hitting a wall wasn't to stop. It was to push in a different direction. Instead of only making models bigger during training, labs started spending computing power differently. At the moment you actually use the model, picture the difference. Studying harder for a test versus getting extra time during the test to actually think. That second idea, giving a model more time to reason before answering, unlocked real gains that pure size had stopped providing. That's a big reason the newest reasoning models feel sharper. Without being bigger at all, there's a quieter shift happening too. Smaller models, trained with cleverer techniques, are matching giants from just a year earlier. A model a fraction of the size can now beat one of the biggest models from 2023. Not because it's bigger, because the training got smarter. For years, bigger was destiny. Now sometimes, smarter training beats bigger. That's why labs talk less about parameter counts these days, and more about reasoning, tool use, how a model behaves across a long task. The old scoreboard stopped predicting who wins. Here's the reframe. Pause. The one that gets lost in all the AI bubble panic headlines. A wall isn't the end of a story. It's usually the moment right before the interesting part starts. Every major leap in this field came from someone hitting a limit and being forced to invent something new instead of turning the same dial harder. So labs slamming the brakes on pure scaling doesn't mean progress stops. It means the next breakthrough probably won't be a bigger version of the same thing. It'll be a genuinely new idea. A smarter way to reason, a smarter way to learn, a smarter way to train. Historically, that's exactly the kind of moment people remember. Nobody wrote a headline about the 5th year of scaling being bigger. People write about turning points, so next time you see a headline about a disappointing model release, or a delayed launch, or nervous investors, that's not necessarily the bubble popping. It might just be the field growing up, trading brute force for actual cleverness. And honestly, pause. That's a better story than the machines kept getting bigger forever. Because it means the next few years won't be decided by whoever has the biggest data center. They'll be decided by whoever has the best idea,